Yes, Simran, Neha, am I audible to both of you?
Yes, ma'am. Good evening, ma'am.
Good evening. So in the last class, we started with this work energy and power chapter. And basics of work done only we could see that work done is Fs cos theta, and in this variable force was left even. Only one, this question was done, the second question was left. Okay, when we talk about the forces 2i cap plus 3j cap plus 5k cap, remember when you have the work done for a constant force, then you use Fs cos theta, okay? And if the force is variable, then you integrate, integral of F dot ds. So see, now one position, it is basically saying that there's an A point, that is the initial point, 3, comma 2, comma 1. And there's a final point, 2, comma 1, comma 1. And the position has been changed from A to B, and the force is given, and it is asking you to calculate the work done. So what you do, you calculate RA. What is your first this RA given? RA is given as 3i cap plus 2j cap plus k cap. That's it. And what about RB? This is given as 2i cap plus j cap plus k cap. Okay. So these are the position vectors given. Now this is just we need displacement. So what we'll do for the displacement vector, we are going to take the final minus the initial. Final is this whole term, that is 2i cap plus j cap plus k cap. Now minus this term, minus of 3i cap. See, when I put minus here, all the signs will change. So minus 3i cap, minus 2j cap, and minus k cap. So what we'll get? Look, 2i cap is there. So the position vector, basically the displacement will be minus I cap from here. Look, j cap minus 2j cap, again minus j cap, and k cap gets cancelled because k cap minus k cap is 0. So you have the position vector with you. And you also have the force with you. 2i cap plus 3j cap plus 5k cap. Okay, so force is there and the position vector is there. So what we do, we know the formula of work done is equal to F dot S, F S cos theta. Now, how do you identify that this is a constant force, that this is not a variable force? This is a constant force because there is no way function of position or function of time coming here. That's why we know, okay, this is a constant force. Fs cos theta. Force will always remain this. We have its x component, y component, and z component. Okay, and the force's magnitude can also be calculated from here. So what we'll do, uh, here you don't require Fs cos theta, you just require F dot S. So this will be equal to work done will be equal to forces to I cap plus 3 j cap plus 5 k cap dot. This is equal to minus I cap minus j cap. So when you multiply, look, 2 into minus 1 is minus 2. 3 into minus 1 is minus 3. Plus 5 into 0 is 0. So this will be simply minus 2 minus 3. That is minus 5 joules. So this will be the work done. Okay. Because this is in Cartesian form, so we were able to calculate. Now we will discuss the variable force. But first copy down this part, both of them. Both of you have written. Simra, you have also written.
Yes, ma'am. Done.
Okay. See, coming to the variable force. Now, see, variable force means, like, look at this force. This force is given as 3x square plus 2x. So you can clearly see that this force is depending upon the values of x. As the values of these two x's will be changing, similarly, time could have been there. This is position given, anything could be there. So this is displacement that is given. Okay. So force is variable, force is depending upon the position. Now, when we calculate for the work done for the variable force, we integrate. Okay, so this will be F dot ds integration from I. In fact, I'll write x because here also x is given. So dx from x1 to x2 when the force is variable. This will just help you in the calculation of the basic work done. Okay. Now see, what will I do? I'll write work done as, this will be force is 3x square plus 2x and dx is there, and integrating it from, now see, it is from 0 to 2 meter. This is from 0 to 2 meter here. This force acts and you have to calculate when the displacement is 0 to 2. So you are also going to put the limits as 0 to 2 itself. Okay. So look, when we integrate, I've already told you for these dx, you just multiply them and separate the integral symbol so that you know what your question exactly is. So work done will be equal to, look, 3x square dx integrating from 0 to 2. That's one, plus 2x dx integrating from 0 to 2. That's the second. Now see, their integration is quite easier. Now when you separate the terms, it becomes quite clear to us. Okay. So that's why when you integrate this integration is a little easier. What we do, see, 3 is there, x square will become x cube. You add 1 to the numerator, to the power. So this is x cube divided by 3 from 0 to 2. Okay, just a second. See, x cube divided by 3 from 0 to 2 plus 2 is there. Now this is x to the power 1 is there. So that will become x squared divided by 2 from 0 to 2. See, these powers will cancel the denominator. So you will be left with just 2 cube minus 0 cube plus 2 square minus 0 square. Okay, so this is 8 plus 4, which is equal to 12. So 12 joule is that. So integration, I think you all will be able to perform. Integration, I hope you remember, integration will be used here because of this variable force. Are the two questions clear? Both of the questions clear to both of you, Simran here? And if my voice comes very low in between, please just text me or just let me know in between. Okay. Please copy down this. Then we will move on to the graphs. One kind of question that come from this topic, these are the graphs. So graphs we'll see. Please write. All right, both of you have completed. Now, see, coming to the graphs part. Remember two things, class. When we discussed the graphs in the, motion in a straight line, that time also remember we discussed the topic of graphs. See, when we talk about graphs, here how it will be utilized is we discussed that whenever we have two things getting divided, like if you have A divided by B, is giving you some C, whatever is this quantity. So when you have A and B and the graph is plotted between this A and B, A is given and B is given. And whatever is this graph, let's say this graph is like this. So I told you that since this is getting divided, the third quantity, that is the C, this will always be given by the slope of the graph. And how do we calculate the slope of the graph? We calculate it using tan theta. Okay, now second case was that if two quantities were getting multiplied, like A is getting multiplied to B and it is giving you C. And here we have the certain graph. Let's say this is A, this is B, and here we have this is the graph. So in this case, they are getting multiplied, right? Both of the quantities are getting multiplied. This quantity, which is the third one, this new quantity that is coming, this will be given by the area under the curve. Like this. If this is my curve. So this whole shaded region, this will be the area under the curve. Okay, now you both tell me, according to you, which one will be applicable in work done? Which will be applicable for work done? What do you think?
The second one, A into
Second.
B is equal to C.
Yes, very correct. Because see, in work done, two things are getting multiplied. Work done is force into displacement. So remember just one thing. Whenever in the graphical method, the work done will be given by the area under the curve. So work done will be given by area under the curve. Under the curve means whatever is the path followed by the graph. Okay, so area is given by area under the curve. That gives you the work done. Okay. Now, work done are also of many types. We'll discuss them. Work done is a scalar quantity. Remember that. But see, anything that is coming above the graph will be positive. It is if it is below the graph, it will be negative. But just remember, you just have to calculate the area, whatever is being formed. Okay. So area above the displacement will be taken positive. Area below the displacement is negative. Now, work done is a scalar quantity, then why are we considering positive and negative? Reason is that you are not considering work done. You are taking displacement. Displacement can be negative, forces can be negative. So that's why. And we'll discuss the types of work done. So this negative part will be clear. Okay, we'll practice this question. Class, please start writing from here. Uh, just once you write, no, just write done. I'll just have to pray and come. Okay, it will just take me 2 to 3 minutes, but otherwise time won't be left here. We already have very less time. Okay, so somebody will scroll for you. Just type it done. And there's one question. If you reach that, just try it. I'll just discuss. I'll just come. Yes, class. Did you try this question?
Yes, ma'am.
Okay, look, this is a rectangle and this is a triangle. So for work done, you have to get the area under the curve. So this will be the area of the rectangle plus area of triangle. Now look here. The area of the rectangle will be simply length into breadth. So 3 into 2 plus. Now let's talk about the triangle. This will be half into base into height. So height is negative. So this will be half into base is 2. Half into base into height. Height will be minus. So this would be half into 2 into minus 2. This would make this 6 minus this is equal to 2. Only 2 is left from here. That is 4 cubits. See class, this completes with the work done concept. Now, as I told you that this chapter is divided into 3 parts. You have work done, you have energy, and you have power. So let's start with the concept of energy. You have two major kinds of energies in your syllabus, but that doesn't mean only these kinds of energies are existing. Okay, various other kinds of energies are also there. Internal energy, entropy, and many energies are there. But don't worry about those energies. Mainly, you have to do these two kinds of energies in your system: kinetic and potential. Now, one thing I'll tell you, though we will do each and every energy in detail and separately, just remember kinetic energy is a function of temperature. This will always help you distinguish between kinetic energy and the potential energy. Okay, kinetic energy is what? This is a function of temperature. While the potential energy, this is the function of forces. And when I say forces, I mean the interaction between two quantities. Okay, now kinetic energy and this potential energy together. If we write the kinetic energy plus the potential energy together, that gives us the mechanical energy. So when we say mechanic, see why? Kinetic energy is related to your movement. Okay, this is all related to your motion movement, and potential energy is related to the forces and the change in shape, orientation, and all. So that's why, in total, when you have both of these combined, that gives the mechanical energy. So, entire mechanics that we have studied, mechanics branch of physics, we are already done with. So that energy which we talked, that was completely mechanical energy which we were talking, but we weren't mentioning it. Now we'll be talking separately about kinetic energy and potential energy. Now remember, to identify kinetic energy, it's very easy. Kinetic energy can directly be identified through movement. Okay, whenever the body is in motion, or whenever the body is moving. Because the formula of kinetic energy from lower classes, you already know, all of you. This is half mv square. Now, what is this? This is the E means for kinetic energy. Half is there. M means the mass, while V means the velocity. Half mv square. And about kinetic energy theorem right now, just focus on kinetic energy's basic formula. What is it? Half into mass into square of velocity. Now, as you can see, velocity is coming into your question. So if this motion term is there and this velocity term is there, so you should be quite clear about it, that the energy possessed by the body due to its motion will come, means your body will be in movement. Okay. Now talking about the work energy theorem. It says that whatever work done you have studied, not just work energy theorem. Work energy theorem in general, this says that whatever work is being done, that work gets stored in the form of any of the energies, not necessarily kinetic, only potential also. So this work then is always stored in some form of energy. This is stored in some form of energy. So this will be stored in some form of energy. So which energy? All of the energies that are present. Heat energy, especially potential energy and kinetic energy, you'll use a lot. Potential energy will come in your class 12th also class, when you'll have electrostatic potential energy. Same theory in every concept. Anyways, let me focus on kinetic more now, otherwise it will be confusing. Now, what is the work kinetic energy theorem, you say, or work energy theorem, you say? It basically says that whatever is the work done that is occurring is ultimately equal to the change in kinetic energy. And there's a small derivation for it. So, do one thing, copy it till here, then let me discuss the derivation of the work energy theory. This question you both have written, Shimra and Neha?
Yes,
Yes,
ma'am.
ma'am. Okay, please write down this part, then let's derive it. Okay, both of you are completed. See, when we talk about this is a block of mass m, and this is the same block which has been pulled due to a certain force. Now, when the block moves with its velocity, let's say the initial velocity is some v1, the final velocity is some v2, and the total displacement is covered from x1 to x2. When I talk about the work done class, here, can you tell me, will the variable force means the variable work done be used or constant? What do you think? Which formula should I apply?
Constant.
No, actually, see what is happening because of velocity is changing. Value of acceleration is also changing. See, initial velocity is different, final velocity is different. So velocity will be changing, and moreover, your displacement is also not fixed. So we'll take f dx integral from x1 to x2. Now see, if I have x1 to x2, let me shift this. Let me make this as, see, f is equal to ma. So I can write this as ma dx, integrating it from x1 to x2. Now look, acceleration can be written as dv over dt. So let me put that. So this becomes dv over dt, right? And acceleration is a. No, acceleration I have already written. This is dv over dt into dx. This is integrating. This is the work. Class, what is this? Can anyone answer?
Velocity.
Velocity. Very good. This is velocity. So look, this will be mv dv over dt. Now here we had x1 to x2 because we were initially differentiating the position, but your position has gone. So you cannot put the positions variables. You cannot put the this position or basically displacements limits. Whatever you integrate, whatever is your whatever is your function, you'll have to take the same limits. So if I take here, I have made this as velocity. So work done will be equal to mv dv over dt. Okay, this is fine till here, mv dv over dt. But we'll integrate it from initial velocity to a final velocity. You can never integrate. This is never possible. Integral, let's say x square dx, integrating from u to v. This is incorrect. Same value should be there. Okay, so that's why we are taking it as v1 to v2. This is what m v. I have written dt, and dt won't. dt we have already considered here. Okay, so mv dt. Now we have to integrate. Mass is constant. Mass is not variable. Remember, we are not taking the variable mass. If mass is variable, use this step. Okay, for the variable mass, but that won't be given to you. Now integration. This becomes v square by 2 from v1 to v2. In fact, if you want, you can write u and v also because initial velocity is taken as u, final is taken as v. So that also you can take. So see m, now what we do, we put the upper limit and then the lower limit. So m v2 square minus v1 square by 2. I'll separate the denominators. M v2 square by 2 minus m v1 square by 2. I have not only separated it, I have multiplied this also inside. Okay, so separation and multiplication. This is the work done. Now look, the final kinetic energy, what is exactly this? This is the final kinetic energy, while this is the initial kinetic energy. Why class? Because see, formula of kinetic energy is equal to half mv square. So final velocity, final kinetic energy, initial velocity, initial kinetic energy. So work done will be equal to kinetic energy final minus kinetic energy initial, that is equal to the change in kinetic energy. So this is basically the work energy theorem that we have to prove. Okay. So this comes to prove work energy theorem is so important class. In class 12th also this often is used and most of the students don't know this. So you have to remember work energy theorem means work done is equal to change in kinetic energy. Is the derivation clear?
Yes, ma'am.
Yes,
Clear.
ma'am.
All right, please write it. Both have completed. Simra, you also? Simra, done? Simra, you there? Yes, Simra. Am I audible?
Yes, ma'am.
Okay. Yes, Simra, have you completed?
Yes, ma'am. Done.
Oh, see, sir. Now coming to the consequences of momentum and kinetic energy getting related. The formula of momentum, what is it? Yes, formula of momentum,
Mass into velocity.
mass into, yes, very good. So mass into velocity. Now let's talk about the kinetic energy. Kinetic energy is basically half mv square. If I write it like this, or in fact, let me do one thing. Rather than writing, if I multiply and divide it by the mass. Now see what will happen. This will be half. This will also become m square v square divided by m. See, if p is equal to mv, p square should be equal to m square v square. So when we put the value here, look, this will be equal to, we can say kinetic energy is equal to half p square by m. So this is a relationship between kinetic energy and the momentum. Okay, this p is the momentum, while this ke is our kinetic energy class. Okay, now this is a very, very common relation used. In fact, in your 12th class also, when you'll have the chapters, dual nature of matter and radiation and all, there this will come. And I think in your chemistry also, structure of atom, this may be used. This might have been used if that chapter is was done. Maybe in that it is used, it's actually a part of quantum physics. Now, there's a question. The question says the percentage change in momentum is 10%. What's the change in kinetic energy? See, initial momentum. Let the initial momentum is equal to P. Finally, momentum is increasing by 10% class. Change in momentum. The momentum is increasing by 10%. So this will be P by 10P divided by 100. Yes, that's how we write. 10% increment. If it's decrement, then we subtract. So this becomes 110P divided by 100, which is equal to 1.1 P. Right? Now it is asking us the change in momentum. Oh, no, change in kinetic energy. All right. So we know kinetic energy. How will we get? Initial kinetic energy will be half, or directly I'll write P square by 2m. This was the initial kinetic energy. What will be the final kinetic energy class? This momentum will be squared up 1.1 P whole square divided by 2m. 1.1 P whole square divided by 2m we'll take. So we'll take for the percentage change in kinetic energy, we'll take the change in kinetic energy class by the original kinetic energy, initial. That's how we calculate the thing and multiply it to 100. Now look, this will be final is 1.1 P whole square divided by 2m minus initial is P square divided by 2m and the whole thing divided by p square by 2m into 100. See, 2m, in fact, p squared by 2m will be cancelled, class. If I take p square by 2m common here, it will be 1.1 in 1.21. This will be 1.21 minus 1 divided by p square by 2m. This gets cancelled in 200. This is 1 minus is 0.21 into 100, which is equal to 21%. So momentum, this would be the change, percentage change in momentum. Percentage, sorry, a kinetic energy, percentage change in kinetic energy. So more importantly, see, this was how you use percentages, but this is a completely new concept, means in the sense that whatever you've studied in momentum, this gets related to it. So momentum part is utilized here, and momentum and kinetic energy, this formula is often used. In fact, this is also used, that value of momentum will be equal to 2mke under root. This formula is often used. So whichever quantity is asked, will you be able to manage the percentage? Is it clear? Shimra Neha?
The percentage
Yeah.
part was a little confusing.
Okay, see, I'll tell you. This is the initial momentum P. Initial kinetic energy will be P square by 2m. Finally, it is increasing by 10%. So whenever there is an increment in the percent, you take original plus whatever is the percentage increment. That is 110p by 100 here. That is 1.1p. So kinetic energy will be 1.1p whole square by 2m. This part is clear to you, or here there is a confusion, Simra? This is clear?
Not
Yeah.
quite.
Okay, here there is a confusion. Okay, let me tell you this. You must be forgetting in your lower classes, no, whenever percentage was what I tell you. Let's say there is an increase in the percentage. This is percentage increase. So what you do, the new quantity, let's say this is the new quantity. New quantity will be given by original plus whatever is the percentage change of the original. This is how it is given. So what we do, this was the initial momentum. And one more thing, when there is a decrease in the percentage, the new quantity is given by subtraction, original minus subtraction of the new quantity. That's how we use percentages. Now look here, this is the original. P is the original. And what's the percent? 10% of P. So P plus 10% of P will give us the new momentum. New is equal to original plus percentage into original. The new momentum will be equal to momentum plus 10%. Now, how do you write 10%? You have the percent. 10p upon 100% means this whole thing divided by 100. Whenever you have to convert percentages into fractions, just multiply it. Percentages into fractions, just divide it by 100. It will give you the fraction part. So 10 by 100 has given same thing. I have written 10 by 100. Then further I have taken the LCM. If this said that this is decreasing by 10%, so I would have subtracted here. So remember this formula, this will be helpful. New quantity will be given by original plus whatever is the percentage in the original, you will add it. Whatever percentage has been increased. It's like P was already there. This was P. And 10% of P is there. Now 10% has increased by 10%. So you are just adding this extra 10% of P which you are getting. And then you are calculating whatever is this total quantity. So this formula, just remember original plus percentage of original. So P plus 10% of P. So 10% is written as 10 by 100. So then we solved it for you. Now, Simra, you got this percentages concept?
Yes, ma'am, it's clear now.
Okay. And here also, when you calculate the percentage change, whenever you have to calculate, like in your school also, when you calculate the marks, what you do? You take the total marks divided by, when you take your own marks, divided by the total marks into 100. So whenever you have to calculate the percentage of any quantity, you take the change divided by original into 100. This is the formula of a percentage. Change divided by original into 100. Change means whatever quantity you've got. Like that's why we calculate the change in our marks. Means if total marks is 500 and you're getting 480, so that will come in the change. So change by original into 100. Change will mean final minus initial divided by the initial into 100. Okay?
Yes,
Is
ma'am.
it okay? All right, please write it. See, class, this question says a bullet weighing 10 gram is fired with a velocity of 800 meter per second. So mass of the bullet is given as 10 grams. 10 into 10 to the power minus 3 kg. Okay. It is fired with a velocity of 800 meter per second. It is after passing through a wall of 1 meter thick distance. This is the initial velocity. Final velocity becomes 100 meter per second, and displacement is also given as 1 meter. It just calculate the change in the kinetic energy. See, change in kinetic energy means final kinetic energy minus initial kinetic energy. This is half m v final square minus half mv initial square, or in fact you can do one thing. Write this as half into m v final square minus v initial square. Okay. When you put in the value half, this is 10 to the power minus 2. This will be 1 by 200 into v final is given as 100. So this will be 100 square minus 800 square. This is what we'll have as our kinetic energy. So look, this will be 1 by 200. This is 10,000 minus this is 64,000, which is equal to minus 54,000 divided by 200. So this gets cancelled, which becomes minus 270. Now see, kinetic energy is a scalar quantity. Kinetic energy can never be negative. So you will take this kinetic energy modulus and you will say simply it is 270 joules. That would be the answer for the first part. Second says work done by the resistive force. Okay, here this was the change in the kinetic energy, half mv square minus half vi initial square. See, for the resistive force, it has said the bullet weight is given as 10 grams. So see, what is the force acting when the bullet is being shot? This is the bullet. It has its own weight, that is mg. So force is equal to mg in this case. Displacement is already given as 1 meter. So force is equal to 10 into 10 to the power minus 3 into g is given as 10. So force will be equal to, this is 2 minus 3, that is minus 1, 0.1 Newton. This will be the force, and displacement class will be 1 meter. Right, so when you calculate the work, in fact, you don't need to even use this. What you can do, apart from this, one method is that you can calculate F is equal to mg part for the gravitational force. But it's one thing, since it is saying no, that bullet is there, a bullet has been fired. So there are chances that when it strikes, when this bullet strikes this, then there are chances there will be forces exerted on striking. That would not be equal to mg. So that's why don't take when you are not aware of all the forces. Mg you can take when you know the net force, okay, by using the free body diagram. Here for the work done, we just use the work energy theorem. Work is equal to kinetic energy, that is 270. Now see, if you use the same thing by the force, mass is 10, so that won't come out to be 217 anyways. It means more force is acting. Third part says, yes, see average resistive force offered. So average resistive, now you have to calculate the force. What is the value of the force? Work done is given. Work done is 270 joules and displacement is 1 meter. So force
Excuse
will
me,
be
ma'am.
equal to, yes, Neha?
Ma'am, 800 square, if there was one more zero missing, so the value will change, right?
Oh, okay, okay. Yes, yes. I have taken 64,000. By looking this, I just put yes, yes. Value will change. This is this will be 63.
Yes, ma'am.
Yeah, this will be 63. So value will change. You're right. This will be 63 minus only, and that would give uh, 4 zeros, right? Divided by 200. Now, see, this way we'll get 2 zeros will be cancelled. So 3, 6, and 5. So minus 3, 6, 3, 6, 5, 0. So this will also be 3, 6, 5, 0. Yes, thank you, Neha. Right. This was incorrect initially. So this would also be 3, 6, 5, 0.
No, ma'am. 3150.
3, 1, 5, 0. Yeah, 3, 1, 5, 0. Correct. 3, 1, 5, 0. So see, when we are talking about the average resistive force, this will also be the same, right? Because this is 1 meter only. So this is 3150 joules. So this will be work done divided by the displacement. So 3150 by 1. This is 3150. Let's see, class, force can be negative. So for force, you can take this as minus 3150 Newton. Why? Because this is the resistive force. Anyways, this force will be negative itself. Okay, because first thing, this is a resistive force. Resistive force means you are getting retardation. This will give rise to deacceleration, that is negative acceleration. So for force, you can put a negative value, rest you can. Okay. All right, class, please copy down this question. Simran, your time is up. You can copy this question in the next class. Okay, or you know the solution also. This much you can write, or just take the screenshot of this page. We'll continue.